it just took a bit for YouTube to catch it. Oh, it says we're live. Okay, cool. Hey. So usually what we do is we go live for about... Usually it's like 30 minutes, but we'll just go live for about 5 minutes, and then we'll actually start the podcast.
Okay, cool.
This is mostly just so that...
people to trickle in.
Yeah. And we typically don't get a lot of viewers. It's usually like 4 or 5. Mostly those because it puts it already on YouTube for us.
Yeah. And there's no like live Q&A that I should be looking at or monitoring, right? Okay.
I mean, we could do that if you want to, but
that sounds like a
lot of work.
Like a dumpster fire, to be quite honest.
Yeah.
Basically, we see if there's an interesting question that comes in from the community, we'll shove it in somewhere.
Yeah.
Great.
But it's not like there's a list and we have to go through it.
Yeah, cool.
Yeah, that would be a dumpster fire. I'm reading through your bio here because I'm the one who reads the bios for guests. Hexagon Manufacturing Intelligence, and then that's Hilti or Hilti?
Hilti.
Okay,
Yep.
Hilti North America. And Mark Forged.
Mark Forged. You guys know those guys?
I know.
I've certainly seen their stuff.
I know Hilti. It's a tool manufacturer.
Yeah.
High-end stuff.
It is that, for sure.
Industrial additive manufacturing platform.
What is... I know I've seen Hilti stuff. Where have I seen it?
AVE talks about them a lot on YouTube.
Ah, okay.
That's
that
where
makes
you
sense.
probably have seen
I've probably
stuff.
seen it there.
Yeah, they're doing some pretty cool stuff now with like AGVs and robots and like installing electrical and plumbing hangers in the ceiling with like a robot or even like an exoskeleton on a human so they can hold their arms above their head for longer.
Oh, wow.
Oh, that's cool.
Yeah, like all these contractors are always out there in these dusty, crappy environments, you know? So LT does a really good job kind of supporting the plumbers, electricians of the world.
That's just a stepping stone to getting rid of the human and just having the robot,
100%.
24/7 go do what they need to do.
Yeah.
Okay, yeah, these look like some really beefy tools.
It's really hard to actually buy them as a private citizen. Like,
yeah,
they have a storefront, but it's really small, and then they just sell through contractors and through big general GCs and stuff.
And that's on purpose, of course.
100%. Yeah.
This is a level beyond prosumer.
Oh no, Hilti is pro. Like they don't.
Yeah, right. That's what I'm saying.
They're not trying to dance around like Milwaukee or DeWalt or anything like that. Or even like Snap-ons become more prosumer nowadays because like you can just go on Snap-on's quality's dropped, but like also you just go on their website and order it. Where Hilti's like we are going to be Pro Tools and that's it. So
yeah.
If you
my job was
costs.
chasing cranes. I got in my car, woke up in Boston, and looked where the cranes are on the skyline. I was like, I'm gonna drive to that big construction site and try and sell some tools.
You just
yeah, seriously.
Yeah. That's pretty great.
Okay, I'm going to. Oh, that was an email about Steven about next week's episode. Okay.
Oh, yeah, you got that? Okay.
Yeah, I just got an email that said Steven has shared a document with you. I'm like, I thought he already shared this document. Why am I looking at this one then? Anyways,
Yeah. Start thinking about stuff.
Yeah. All right. We're going ahead and just go ahead and start. Yukoi?
I'm good. You good, Riley?
I'm good.
Okay. Welcome to the Macrofab Engineering Podcast, a weekly show about all things engineering, DIY projects, manufacturing, industry news, and designing enclosures for electronics. We're your hosts, electrical engineers, Parker Dolman.
And Stephen Craig.
This is episode 371.
So our guest this week is Riley Hall. Riley is the Director of Product Marketing for Fictive. He has over 10 years of experience working in highly technical manufacturing engineering environments at companies including Hexagon Manufacturing Intelligence, Hilti North America, and Markforged. Riley holds a BA in Mechanical Engineering from the University of Michigan, as well as an MBA from the University of Colorado Boulder, and lives with his wife, Hannah, in Denver, enjoying hiking, skiing, and the occasional Colorado brewery.
Thank you, Riley,
Thanks,
for coming
gentlemen.
onto our podcast.
Yeah, awesome to be here. Thanks so much for having me.
So before we completely jump into fictive and enclosures and all that stuff, what is your favorite Colorado brewery?
My favorite Colorado brewery. I like this place called Acreage. So it's up north of the city a little bit. They got this big outdoor area. You look over the mountains. You can bring the dogs, let them run around. The only scary part is when my dog knocks over a small child who is also running around. So other than that, an awesome place to be.
That sounds pretty normal for a brewery out here.
Yeah, definitely.
All right, cool. Riley, what is Fictive?
Yeah, so Fictive is a online platform that offers manufacturing services for companies and consumers of all sizes and shapes. So we specialize in CNC machining, injection molding, and 3D printing. We also do some urethane casting on the side, but we're really working to connect new product development engineers and R&D teams into a really vetted supplier network to get your parts turned around quickly at a cost that makes sense and at a quality that you would expect from your shop around the corner.
So Fictive kind of does the Macrofab style platform thing, but for your mechanical items.
Yeah, exactly. If you think about it for like custom mechanical parts, right? We don't do a whole lot of screws and bolts and washers, but if you think about like complex, custom designed, manufactured hardware components, where you can't go to an Ace or a Home Depot and just pick it up, right? It's something that you've drawn in CAD and you want to get produced, but you might only need 1 or 100. And, you know, those big injection molding suppliers or big CNC shops won't really give you the time of day, right? Because they got gigantic corporations spending millions of dollars with them. So we see every customer as a giant corporation, right? Even if you're somebody in your basement doing your own DIY projects, or you're on an engineering team of 4 or 5 people working to bring a new innovative design to market. Fictive is really good about bringing in your design, giving you the design for manufacturability feedback, and really pairing you with the best suited manufacturing partner for your specific component.
Yeah, it's not so much about buying the 3-inch long quarter 20 bolt, but about the fancy bracket that you need designed and manufactured that bolt goes into.
Yeah, in other words, you do the hard stuff.
Yeah, we do the complex and the hard stuff, right? And we know that individual engineers are focused on their part or their component, And Fictive is really experts in analyzing the whole assembly, right? So while you might be worried about that bracket, you're not worried necessarily or responsible necessarily for how it interacts with all of the other components in the assembly. And we help customers think through that, redesign for that, and really get parts made that are, plugged in to the bigger picture beyond just the bracket.
I've been working through a CNC build for the past, I don't know how many months, Parker, a lot of months. and I manufactured all of my own parts, milled
Sure.
all of them except for one that was a part that I can't do. And now I might be turning into Fictive on this because I'm realizing you guys can actually probably make this part that I couldn't.
Yeah, send it our way, right? And we're really good about saying what we can't make as well. I think that's really important. We're not going to lead you down this rabbit hole just to say like, hey, give us your money, and then we're going to send you a part that doesn't work. Like, we would much rather tell you up front that it's not going to work and we can't do it than play the game, right? So, yeah, we'd love to give it a shot, Steven. I mean, send it our way.
So it's not even just about it won't work, but you can tell Steven how it wouldn't work, right?
Yeah. So on platform, pre-purchase, so before you even check out, we have instantaneous design for manufacturability feedback. So it's a pretty interactive platform. You upload your CAD model, drag and drop, or click upload. We analyze the geometry using an ML engine, so a machine learning engine that's done hundreds of thousands of parts. And we tell you specific geometries that may not be able to be manufactured by the process that you've selected. So if you think about 3D printing, right, we'll highlight thin-walled areas, and we'll actually highlight it in the viewer. So it's a 3D viewer where you can spin the part and see the exact piece of that geometry that's flagging the warning. And we have two levels, right? We have warnings and failures. So a warning is like, hey, this is close. We could probably make it, but if you can redesign, let's take a look at redesigning it with you. And then a failure is like, hey, we're pretty sure that the way you've designed it isn't going to be able to be made.
I find that to be really fascinating that you mentioned machine learning in that, because if you go to, say, a classic machinist with a drawing or even with a finished part, you can usually hand it to them and they'll look at it and be like, okay, well, it was probably made by doing this process first and then that process and then this. And, I square this face and then I drilled it. That they can usually step through at the processes to get from raw material to the finished good. So does your machine learning algorithm attempt to do that in terms of like it's thinking about the raw material and then thinking about going towards the finished good?
Yeah, 100%. I think that's a really good call out, right? We, as a manufacturing community, know that there's a lot of tribal knowledge in manufacturing, right? And we know that a lot of that tribal knowledge is like aging out. So, Fictive is also a tool for upskilling these young mechanical engineers and young design engineers to get them thinking about that manufacturing process. To answer your question more directly, yes. So not only do we provide the instant design for manufacturability feedback, but we actually present an instantaneous quote on the part. And the way that we get to that quote is exactly what you described, Stephen, right? So our engine is like analyzing the geometry, saying, okay, I know that I'm going to have to set this part up in 3 different fixtures. I know that I'm going to have to use a lathe and then a mill, right? And then I'm going to have to tap it. So the engine itself looks at the geometry, and because it's analyzed so many parts and because we have a really kick-ass group of super nerdy computational geometry engineers that are awesome, like the algorithm is doing exactly that. So we're working to build all of those setups and fixtures and machine types into not only the design for manufacturability feedback, but also that costing algorithm.
Wow, that's really impressive. Just because I think that kind of thought process comes really easy and naturally to humans to look at a thing and be like, I've never made this thing before, but here's the things I know I'm going to need to do, the XYZ in time in order to get to there. But to have a computer do that is incredible.
Yeah, and we're of the belief that the best automation is human plus machine, right? So like we start with this algorithm and we're like, okay, this is probably what it looks like. But every part that we produce, one has fictive quality engineers that inspect quality before it goes out the door, but two has technical program managers or technical applications engineers really thinking about the setup. And like we're looking at it and saying, okay, you know, this engine said that it'll be 4 setups with 3 different fixtures. Can we get it down to 3 setups? You know, can we think critically about how this part would actually be made, and you know, tweak the pricing and the manufacturability from there. So it's really a guided expertise experience. It's not a marketplace, right? We don't take your design and then ship it out to 100 people and say, give me your best price, and then present 100 prices to you, the customer. What Fictive is really a managed, vetted partner network. And so based on our algorithm and based on your material configuration, right, the type of machining process that you want to use, we take all of that in, and then we stack rank the manufacturing partners in our network and match you to the best one in that network, right? So we're presenting a price to a person who we know can make it, who can meet your deadline, and who we have really high level of trust in terms of quality and delivery.
So when somebody reviews the, I don't know, the 4 steps and said, hey, I can do it in 3, does that get fed back into the algorithm to kind of refine the algorithm?
Yeah, so great question. We have an awesome gentleman on the team who's solely responsible for that type of feedback, right? So not only is he looking at parts that we've done, he's looking at and talking to our customers regularly about what they're seeing from other suppliers and other vendors, right? And then we're constantly tweaking and changing that algorithm to get better from a price standpoint, right? We know that a lot of our customers, especially if you're a smaller company or an individual person, are price sensitive, and we're aware of that, right? We don't present ourselves as the cheapest option.
Hey Riley, we lost your microphone.
Oh, sorry. How about now?
It's a different microphone.
It sounds like it changed to a different mic.
Oh, weird. I'm sorry, guys. Give me 1 second.
No,
No
you're
worries.
all good? Yeah, where there's a lot of echo now.
Let me. There we go.
Parker's patented
12:30.
slap.
Well, that's just so I can see it on the editing screen.
Yeah. Here, you can have some coughs too.
Thanks.
Do you guys know?
That sounds good now.
Yeah, you're back on your other mic.
We're better now?
Yeah.
Wait, hold on. What about now?
Yep, you're good.
Weird. I didn't change any of the settings. What's the setting button if I do need to change them?
There's a little gear icon, I think.
Yeah.
For whatever reason, it just went blank and then switched to another mic.
Weird.
Yeah.
Well,
All right. It's showing that I'm using my AirPod microphone, which is probably not the best, but
it's what you
if it
were
sounds
using.
good, I'll
And...
cook it.
Uh-oh.
We'll be all right. We're coming back.
Okay.
All right. So settings. The heck? No, it won't let me. It won't let me change any of my defaults.
What's probably
Different
back
camera.
with different camera. All right. Keeping us on our toes.
I don't really want to use that camera. Shoot.
If it's easier, you can always exit the stream and you can come right back in.
Okay, let me try that.
Hey, hold on.
Oh yeah. Right.
Let me. Okay, now you can go.
Sorry.
Sorry. Yeah, I should have mentioned that.
Yeah. Okay, so I have it where it started on that track, so I can
Okay.
edit it out. Do the pre-editing for Josh, because Josh always gets confused when I send him like 8 tracks for two people, and he's like, "What? Where do you want me to cut this? Yeah, where do you want me to cut this?" And I'm like, "I'll just cut it for you. Don't worry about it."
Yeah. Thank you.
Yes, I do a pre-cut.
Yeah, he's probably happy about that.
Oh yeah, this saves him a lot of time. I'm actually like thinking about it.
Okay.
All right.
Good.
Yeah, we're good.
That was weird.
Yeah. Let me,
Okay.
hold on,
Before
hold on.
we go
Yeah.
back,
Yeah.
where were we at?
You were mentioning that fictive is not the cheapest option. I think that's
Okay.
the last thing you said before.
Yeah, let me
darkness.
make sure we're all good to go on.
When you guys kicked me out of the stream. We're not the cheapest. All right. See ya.
Yeah, that's it. Yeah.
I'm just trying to make sure that I've got your audio from beginning.
I have to admit, I really like how earlier you mentioned. I'm not remembering or recalling how you said it, but you said like in our off time we do urethane casting or something like that. I really like that because that's such an engineer's approach. Just for fun, I do some extra chemistry on the side.
Yeah.
I've worked a little bit with urethane before, and it's either like really cool or a nightmare.
Yeah, exactly, right? And it's there's usually a better way to do it.
I like that. You know what? I think I might make that my new mantra. There's usually a better way to do it.
Just making sure.
Can meet your deadline algorithm, right? We don't.
Oh, good. So I was just making sure because you sometimes when like the audio devices switch, like Squadcast loses its mind, and thankfully, I was like I downloaded mine and I had like an extra couple seconds of audio, and it basically cut off the recording when your mic switched for some reason. So we got it. It's all fine.
Okay.
Okay.
So we are back to people in YouTube land can see how sometimes podcasts doesn't always work out. So
It's not as glamorous as you think.
no.
It's a good thing that I don't have to repeat anything because I blacked out, so we're good.
It's all blur. All right, we're good to go.
All right, cool. So, Steven, do you want to ask that question again? I think we're talking about how, we as Fictive are really, this match service and not a marketplace, right? And we know that getting a good part is better than getting the cheapest part, right? So the way that we talk and think about that from a Fictive perspective is it's cheaper to do it once than it is to do it 3 times, right? So because we are like quality focused and our platform is matched to a relatively low number of manufacturing partners, right? I think we have like 250 people in our network that actually cut chips and make parts for us. What that allows us to do is really manage them appropriately, right? So we have like quality standards, we have visual inspections. Every part that gets made on a fictive platform, inspection photos of the actual part are taken before the part is shipped, and they're available right on the platform. So you can go in, view inspection photos, you can see your part while it's in transit to you, right? And we do that intentionally, right? There's these marketplaces out there who have thousands of, manufacturing suppliers, and that's what they are. They're suppliers, and you can feel that when you use their service, right? It's like, hey, send me your CAD, and I'm just gonna like ship it out and not think about it because it's one of a million parts we're trying to do today. Like Fictive is all about building relationships, and that's relationships with our manufacturing partners and relationships with our customers. And the more that we work with people, the more we understand what they're looking for, what the projects they are working on that they're designing these components for. And our applications engineers are tied into that, right? And that's another piece of design for manufacturability is, hey, we know that we can do it with this capability, but does that capability match your project and match your timeline and match all of the other components that you're waiting for?
So this is not the first time that we've had Fictive on the podcast. Way back in episode 187, we had Mike Geyer from Fictive to come on to talk about the state of hardware report for 2019. So I'm curious, based off of what happened in 2019, or what's happened between 2019 and 2023, if you want to touch on that a little bit, Riley, what's different about the state of hardware?
Yeah, so the State of Hardware Report, or as we call it now, the State of Manufacturing Report, is still an annual report that comes out of Fictive. We survey a vast array of our customers and some of our prospects, right? People who haven't used us yet, but really try and understand where hardware development, mechanical component design is. And since 2019, we all know the pandemic situation, right? And what we've seen from the responses so far this year is really that strain on the supply chain. It continues to be a massive problem for everybody. And that's true in new product development and new product introduction as well. These R&D teams are struggling to find capacity to get their mechanical components made. And again, this is where Fictive is really uniquely positioned to help, right? And we're really designed to de-risk that procurement of parts. So because we have no minimum order sizes and because we have different capabilities, again, across CNC machining, injection molding and such, we have the ability to get you your parts and maintain your timeline. I like to say that Fictive will be your least crappy supplier. And, we can all, as engineers, understand that, suppliers are mostly difficult to work with. So Fictive just wants to be the least sucky one, where we're not going to push your timelines out because we tell you what we can do, we do what we say we're going to do, and you get your parts in hand with an inspection report and with quality photos when we say we're going to get them to you.
I really like that because it's a really realistic way of putting it, and that's not to say that like generally people are crappy or whatnot, but I can't tell you how many times I've heard that. I've just heard people saying like, I just want someone to get the job done. I just need my parts. I just need whatever. You don't have to, be the best guy out there. You just have to suck the least.
Yeah. Right. You know what I mean? And like, we know that we don't make full assemblies, right? Like Fictive doesn't make PCBs, right? We don't do a lot of electronic components. And so we know that we're not always the longest pole in the tent on your project, right? But we will deliver the parts when we say we're going to deliver them, and they're going to be right the first time. And we know, to engineers, there's a lot of value of having my mechanical parts in a box on my desk while I wait for my PCB to come in, right? Because then as soon as I get it, I can assemble everything and I have my final built project. There's not this lag, there's not this wait, there's not this rework cycle where it's like, oh no, my part's now holding up the assembly and my company's not going to launch this product because I couldn't get it here in time. Like, we know there's value in that, and not only financial value, but just like trust and capital, right? Like, again, we want to be your partner in new product development, and we want to get you your mechanical parts, whether the most critical parts or not.
So dial it back a little bit where you were talking about basically people are having a lot of problems with supply chains. So I guess my question there is it, do we know why that's the case?
Yeah, I think one pertinent example is like, let's take oil and gas just kind of as an industry, as an example, right? Oil and gas is a handful of really big companies that make like pipes and pipe fittings and, very large assemblies. And it's kind of a boom or bust business because these projects are huge projects that take a lot of time, right? So they have a need, and they have a need for a lot of stuff. But then when they go to the field to install this, they no longer have the production need, right? They're like installing something, and their next project will be in 2 years. So oil and gas is interesting because they like have really, really high demand in these short, like spread out periods, which is the worst situation for suppliers, right? Suppliers are looking for like predictability, and I know I'm going to get this many projects from this customer every month. So like, that's one example where the supplier customer relationship never really gets to like a point of partnership, because I need you and I need you, and then I don't need you at all in between, right? And again, because we have distributed manufacturing or on-demand manufacturing, right? We have this 250 shops that we do business with every single day, so that when your part comes in, we already have the relationship, we know the capacity, and we're not stacking up a queue against ourselves. When we look at local manufacturing shops, if you have a guy around the corner who does all of your brackets, to go back to your example, Parker, right? Your guy around the corner does all of your brackets, and you know that you can get a bracket turned around in 5 days on his CNC machine. But then you have a critical project come up, and he's working on somebody else's bracket, and your design gets pushed out to 10 days, right? Just because that's how the queue is set up. What Fictive has is essentially unlimited capacity, because we can manage across our entire network for your one part or your 1,000 parts or your 150 parts. So like, just the resiliency that we build into that supply base and de-risking either like a single supplier or de-risking managing 50 suppliers, because that is also a nightmare, right? We do all of the management and we do all of the procurement for you. So you're not, if you're working on an engineering team at a larger company and you know that the guy around the corner is good, to get him onto the company's approved vendor list and do all of the paperwork and make sure that he gets the job is a process, right? So you do that across 10 shops for one engineer, multiplied by 50 engineers, and all of a sudden you have this gigantic approved vendor list that needs to be vetted and managed every year and groomed, right? Some of these companies go out of business. Some of these companies no longer offer that material or that process. So it's kind of a double-edged sword in terms of like where Fictive helps with supply chain concerns. We help when you need us, and we help if you have consistent business as well in terms of managing that relationship. I think one of my favorite taglines is let engineers engineer, right? And my point is, like, if you're a design engineer or a mechanical engineer, you got into that field and got that job because you want to draw innovative you want to create innovative products, right? And you want to sketch them and you want to 3D model them. You don't want to be on the phone with a supplier asking them what size sheet metal they have on the floor and if they're going to be able to make that design, right? So my tagline is let engineers engineer. Like, you give us your design, we'll go get it made, and you can go design the next thing.
Yeah, this is on the electrical engineering side, but when I mean, supply chain still it's not as bad on electrical components as it was, but when it was really bad about 2 years ago, I saw a lot of my friends basically stop designing because they were becoming procurement people, and most of their design work was in fixing procurement problems, and that was not fun to them anymore, and they basically stopped doing it. So you're totally
100%.
right about that.
Well,
Yeah,
I also
and then
think
go
that
ahead.
well, I think that engineers are becoming a lot more multidisciplinary in their own field. So many times, I can't tell you how many times we've talked to electrical engineers who are also designing the doing the system level design, doing the integration of the enclosures with their PCB stuff, and they may not be experts in that field, but yet that's still on their plate to do. Even though they're sweating and stressing over their electrical design, they're like, oh, I still have to do this mechanical stuff on in addition to it, which I feel like places like Fictive are great to just be like, here, I need 5 prototypes, you guys take care of it, just get them to me and they'll work.
Yeah, and I think that's why, historically manufacturing has been such a relationship game, right? There's always been that local job shop where you can like walk in and say, hey, here's my PCB, I need to make an enclosure for it, help me, right? And there's a lot of value in that, right? But there's a lot of risk in working with a small shop with limited capacity, right? And limited quality. So Fictive tries to blend that line. And that's why we have applications engineers. That's why we're a consultative service, right? So like, you can come and bring your design to us and we'll help you just like that. But we know that we have the capacity on the back end to fulfill. You brought up enclosures. I think this is like super important in terms of PCB design, right? Because you're right. I think these engineers are becoming more multidisciplinary and starting to think about the electromechanical system rather than just the electrical system is important. So, where am I going to put the holes on my board so that I can screw it into the enclosure and not mess up any of the traces, right? And like, what clearance do I need? And how do I know that it's going to be supported properly? And all of that stuff is stuff that we can help with. So, when you think about relatively fragile PCBs, you start designing enclosures to support them in the right areas, whether that's with ribs or with bosses. You start to think about how is this going to actually go into the assembly. And then you start thinking about process, right? Do I want to 3D print this or do I want to injection mold this? We see 3D printing a lot when we're making, under 50. It's relatively affordable and we can change designs quickly. But if you're an engineer who is working in new product development and in prototyping, and hey, I'm going to make 50 of these now and test it all out, but then I'm going to make 5,000 and I want to injection mold those, right? Like, Fictive is the perfect partner because when we look at the design and we have that conversation, we're actually going to start to make your 3D printed design moldable, right? So like, we're no longer just designing for 3DP. We're designing for 3DP now, knowing that it's going to be molded, right? So we're really thinking about like uniform shell thickness, shrinkage and cooling, right? And how that part is going to change when it goes to injection molded, where we might not see those same things when it's 3D printed.
Oh, that's interesting. So you're thinking about future processes while currently thinking about what's happening right now.
Yeah, and I think again, it's just that it's that human touch that makes us different, right? Like if you go to a marketplace online and you upload your design and you select 3DP, they're only looking at 3DP, right? We try and understand holistically where that project is going. And there'll be times where it will only be 3DP, right? But in the future, if you're going to want to mold it, you're not going to want to change your design after you validated the prototype in 3DP, because now you got to make more of them and 3DP takes too long, right? So let's think about the injection molding design during the prototype phase, even if we're going to 3D print it, so that when it gets to IM, we know we can make it there too.
Mm-hmm. And also just like makes it so that your enclosure at the prototyping stage is still more like how it's going to be in production.
Yeah, for sure.
And funny enough, this is not particularly with DFM, but I've talked about on the podcast before where like if you're designing a 3D printed part or bracket or something like that, adding a little like a draft angle to stuff, even though the 3D printer doesn't need that, it actually does make your part look better. And I don't know how to explain that, but it does. And the funny thing is, I've mentioned this before, and then we've had people comment back saying like I've done that to my design, and it does look better. And I don't know why, but for some reason, doing that does
2
make it look
degrees.
better.
2 degrees is all you need.
Yeah, but like a 3D printer doesn't need that to build the part.
No.
But
Yeah.
it's just funny how it just. I think it goes to our mind where like for some reason injection molded parts look. I know I'm getting off track here. Injection molded
Psychological
parts
conditioning.
they look more professional, right? And like an actual part. So that in your brain, when you look at a 3D printed part, you go, "Oh, that's 3D printed." But if you make it look like an injection molded part, it tricks your brain, right?
Yeah.
Okay, so real quick, I've got a tangent that's still on point a little bit because this is a first for me. Last weekend, my wife and I celebrated our anniversary, and we decided to go to a Brazilian steakhouse because my wife is awesome, and she was down for that. And so at this steakhouse, they brought out these little flags, which were basically 2 inverted pyramids connected together, and one side was red and one side was green. If you were willing to accept steak, you would flip the pyramid over green, and people would come over and drop steak on your plate. And if you were not wanting to have them come, you would flip over for red. Every single one of these little flags they gave you, all of them were 3D printed. Every table in the entire restaurant had 3D printed flags. And I started thinking about it. This was a chain restaurant, and they have restaurants all over the United States. In the one location I had, there was probably 100 flags on the floor, and there was probably in the back they probably had another 100, and that's for one location. Multiply that by the locations all across the United States. They probably had a need for many thousands of these to be made, which, in my opinion, like that's totally a candidate for injection molding. They could have had these injection molded and had that more quote professional look. But they opted for 3D printing, and it's very clearly FDM printed. Like, they had all the lines on it and everything, and, like, I could even see in a couple places that they were not fully perfectly printed, but for this professional restaurant, they were fine with that. And it kind of brought a smile to my face because it was like, okay, this is now becoming an accepted option for a professional business to utilize and just say, like, yeah, we made it this way. And of course, I'm probably the only person in the last year who looked at that and was like, huh, how do they manufacture these little beef flags, for having dinner? But I thought that was cool that it's like, okay, I'm starting now to see that.
Yeah, and I think it's a fun tangent, but it's such a relevant tangent, right? Because we are seeing 3DP be more accepted in the professional B2B landscape. But we're also seeing on-demand manufacturing being more accepted on the B2B landscape, right? And like the companies that we're working with now are Fortune 100 companies, right? We're working with some of the biggest EV vehicle companies. We're working with aerospace companies. We're working with medical device companies. And like this, idea that it's becoming more accepted because it needs to be, right? Because people want to go faster, they want to go cheaper, they want to go better. And historically, it's been a trade-off between speed, quality, and price. Like, pick two, right? But I think that's changing even a little bit. I think you're now able to get all three of those for your new product development and for your R&D teams. And it's really exciting as somebody who's been around manufacturing for a long time to see this shift, both with 3DP, but also with on-demand manufacturing and AI, ML in general, right? And how these new technologies are really changing the landscape of a historically pretty slow-moving industry.
Yeah, especially with smaller OEMs and being able to support when basically smaller batches of their custom manufactured parts. That was actually kind of like the idea behind Macrofab too, was a way for small OEMs to kind of break up their batches and enable them to not have to place huge orders with a manufacturer they might not know too much about.
Yeah, I mean, if you bring Fictive back to its roots, right? Like, we started doing that for 3D printed components in the San Francisco Bay Area, and our founders like printed them and delivered them on scooters, right? Like, years ago, this is how we got our start. And it's only grown, and the industry has only changed to where now the ability to produce injection molding T1 samples, in 10 days is something that we can do, right? Like, we can take your part design, we make the mold design, we cut it out of aluminum, we hit it with injection molded parts and send you samples. You can have them as quick as 10 days. Like, it's crazy to think that the industry has gone so far in such a short time. But yeah, I mean, you're spot on. The small, innovative, fast-moving companies are like people that we share a mindset with and love working with and work with a lot.
Also, just the fact that there's a need for that. There's a need for somebody who wants to get injection molded quality in 10 days.
Yeah, insane, isn't it?
Yeah.
Yeah, I think we've talked about that on the podcast before, but it's one of those a 3D printed part might be fine for prototyping, but when you need to go show it to investors or something like that, having that injected molded part really goes a long way. I back when 3D printing was new and like you were first starting to get your first like kind of like desktop units, like that was like it would wow investors, but now they look at that as at least in my experiences, investors typically will look at that as like even before prototyping it, really. Like they want to see more of the finished product, and will be because when they see the 3D printed part now, they assume that's going to be the final product, and they're like, "Oh, it's 3D printed."
Yeah.
Well,
and
you've mentioned that before, Parker, where you've done an FDM print, and someone was like, "Ugh," and then you just went back and did a UV print and brought it to them. It's still 3D printed, and they were like, "Oh, this is great."
Yeah, exactly. For some reason, it just has that look to it, and some people are fine with it, and some are not, and it's just interesting. And so, like, that's the thing is, like, having such a quick turn injection molding could really change, how, like, if you're a startup and you've got a big presentation coming up, you might want to think about it as an option.
Yeah, I think the story that we like to tell is that whole evolution, right? Is like from 3DP to IM, like matching the story from prototype to bridge production to full scale production, right? And like full scale production injection molded is like a super slim margin game with a very small handful of really big players, right? And like we know that they are best set up for production injection molding. But before you get to hundreds of thousands, like let us help you with that transition from prototype to bridge and from 3DP to IM. So then when you're going to full scale production, you're still taking an IM part. Yes, maybe it's soft tooling, right? Aluminum tooling instead of steel, but you're taking a proven, tested injection molding design to one of these experts with quantity where you'll actually get them to listen to you.
Yeah, if anything, in the last handful of months, well, a few years, I've learned that injection molding is voodoo, and being able to test some things like plastic doesn't flow. It flows in such a weird way that being able to try things is really really helpful before you commit to a 10, 20, $30,000 mold, you know.
Yeah, and we just released something on the Fictive platform that is 3D visualization for injection molding, right? So we'll like show you your mold flow analysis and give you a little playback video and say like, hey, based on your design, this is where you're injecting. Here's your eject pins. This is how the part's going to cool. You know, this is the dimension that you're going to see shrinkage in. And like all of that's built into the Fictive platform to help you as the engineer conceptually understand, like, because I designed it this way, here's what's going to happen to the end part.
So the designer can then go and modify things and just see basically in real time their results. That's cool. That's really cool.
Yeah, so we call that IM 3D visualization.
That right there is the kind of thinking that is probably decades of knowledge that somebody can learn by just upload a design, see how it fails, change something, and then see how it works just through simulation, right?
Yeah, and I mean, I can say this because I'm an engineer too, but like we're kind of curmudgeons, right? And like we want to see how it's going to break. Like show me how it's going to break and how it's not going to work. And then I'll go fix it, right? But if I just don't get any of that feedback and then I get a part and I try and assemble it and it breaks during assembly, like that's worst case scenario because now I got to start over. So we're trying to get involved earlier on in the process and during design and giving our customers that feedback and that guidance so that when you get a part, it's a part that's going to work, it's going to perform with its design intent, and it's going to be right the first time.
Well, perhaps it's a little bit sad, but the things that break sting a lot more than when you get pat on the back for when you did things right. So we do kind of focus on when the things break more than when they go right.
Wait, you get pats on the back?
Yeah, right. There's an infinite amount of ways for the thing to go wrong, and there's like one way for it to go right.
Yeah, 100%. I think that's spot on.
So one more thing I want to ask about before we let you go, Riley, is about material selection, especially for these enclosures. And is there anything you can expand on that?
Yeah, so I think, you know, specifically for electrical enclosures, there's a lot of different considerations, right? There's ESD considerations, there's waterproof considerations, there's weatherproof considerations, there's UV considerations, right? Is this going to be outside? And I think that, again, with how we operate as a company, we want to help you through those questions. Like, we don't expect you to know that I need nylon 12 glass filled for your enclosure, right? Like, we want to hear your problems and we want to help you through that process of selecting the appropriate material. I think the material selection is one component, but if we work from the foundation of design intent and like, how is this going to be used? Right, there's a lot of other considerations that go into it than just material. Again, manufacturing process, speed, cost. interaction with other components, right? So it's not a question that I can answer straight out, Parker, and give you like, here's the 2 materials that you should use for your electrical enclosure. But it's
Come
like,
on, you mean you don't have all the answers?
Manufacture everything out of titanium, and then it will never fail.
Done.
Yeah, exactly. Unlimited budget titanium electrical enclosures. No, so I think my answer would be like, come talk to us, come check it out. Let's see what we can do. Like, our company was founded by engineers, for engineers. Like, our founder worked at Ford and saw that he couldn't get parts fast enough for R&D. So like he went and built a company around this idea of like, let's help new product development engineers get the parts they need, regardless of process and regardless of where they're located, and make sure that we can build it fast with high quality at a reasonable price.
Well, that sounds really awesome, Riley. I wanted to thank you. Oh, Steven, do you have any other questions for Riley?
No, I think I'm good.
Cool. Thank you so much, Riley, for coming on the podcast to talk about fictive and state of manufacturing. Oh, actually, speaking of that, we were talking about a little bit before the podcast about how you are starting to do the state of manufacturing report again. Well, you have been doing it, but there's a new one coming out soon.
Yeah, so we're just starting our surveys for that. So if anybody listening wants to be a part of that survey response, generally we'll ask questions around new product development, around how you've seen your suppliers' landscape change over the last year. Has it gotten better, worse, harder, easier? And kind of trying to understand, are you guys working with more domestic suppliers, more North American suppliers? Are we still overseas using offshore suppliers a lot? Really general questions about your business, anonymously submitted. But if you want to be involved, please just shoot me an email, riley.hall, Hall, @fictive.com. And we'll get you in the queue, and we'll send you the survey, and you can be part of the Fictive 2023 State of Manufacturing Report.
And with that, that was the Macrofab Engineering Podcast. We were your hosts, Parker Dillman
And Stephen Craig.
Later, everyone.
Take it easy.
Thanks, y'all.
Okay, just hang around while it uploads.